All right, hey guys, welcome to day 2 notes. Hopefully, you found day 1 not too challenging and you're able to go through the document quite easily. Remember, you can always message me on D2L, or if you would like to send me an email, always make sure that you voice that for yourself, especially during an e-learning course, so that I can help you as best as I can. Okay, so today, as you've noticed, pretty much how e-learning works, or I guess summer school works for a remedial course, we're pretty much going to be doing a unit per day. Okay, so a unit per day basically condenses about 2 to 3 weeks of work and puts it into that 5 to 6 hour day span, which is why you might notice that there are a lot more notes. If this is the first time that you're taking summer school at the remedial level, you are expected to do about 5 to 6 hours of work per day, and go through the modules, go through my lesson notes, and then there will usually be some sort of multiple choice quiz thing that you will have to go through. Okay, so also keep in mind tomorrow, which is Friday, or if you're watching this on Friday, July 3rd, we will be meeting on Zoom for the first time. Okay, so that's 12 o'clock. So again, make sure that you log in with your first and last name so that I can admit you into the room, and we can have a little introduction. I can talk a little bit about the direction of the course and some of the expectations that I have for you guys. And of course, if you have any questions, you can always ask and I can clarify them for you. So I'm going to just have a discussion today on day 2 notes. Okay, so day 2 notes, just to go over this document first, I have highlighted and organized it very clearly so that that can help with your home learning as you guys are going through this document at home. Okay, so it is a PDF. There are 12 pages in total. Each topic is equivalent to like a section. So pretty much when you guys have regular school, like you did in math at your own home schools, you might have gone through one section, sometimes 2 sections per day, but usually one. And in that one section, you would talk about certain topics that obviously are connected to a particular unit. So for a unit, we're going to discuss polynomials and algebra. So anything that's highlighted in green, if you haven't picked that up already, is a topic. Okay, so topic A is Intro to Algebra. Topic B is collecting, adding like terms. Topic C is degree of polynomials, and so forth. So there is a topic that is discussed, and in total, I believe there are 8 for this particular unit. Okay, I'll address more so tomorrow what your math journal activity will be that you can work on Friday and over the weekend, that will be due on Monday at 11:30 p.m. But I just wanted to go over what to look out for in this particular document. Now, what's highlighted in pink, so I'll start back at the top again. You'll notice in pink where it says you try, group activity B, practice, practice, and so forth. Okay, these are questions that you can practice on your own at home and are expected to practice as well. Okay, you'll notice there are some answers that are found at the bottom of each page. Okay, and that's for some questions, and then for some that might not be available to you. But basically what I'm going to do in this lesson is I'm just going to go over all the work for day 2 in a lesson format. So if you are visual and if you are auditory in terms of learning styles of preference, you could just listen on this YouTube video and work with the video to help understand your PDF as a lesson format. Okay, and then again, if you do have any outstanding questions, I do welcome your questions tomorrow during our Zoom. So please ask them, bring their questions, and yeah, we can go from there. Okay, so pretty much this section is on algebra, and it first goes into the idea of discussing what polynomials are. Okay, so let's just start with the definition here. The word algebra is derived from the Arabic word al-jabr, which means the union or reunion of the broken parts. Algebra is a branch of mathematics that substitutes letters for numbers. Algebraic equations often look like long lines of numbers and letters. So you can see in the example here, it is numbered for you. So you'll notice this is actually called a trinomial, and it's a trinomial because there's 1, 2, 3 terms in total. Okay. with that, there are a couple of things to keep out for. So exponents, you can see the x squared represents the degree in this case. Okay, so it's the highest exponent. The word degree represents the highest sum of exponents per term. And we'll talk about that in a bit. The coefficient, okay, so you'll notice number 2, which is highlighted in green. 2 represents your coefficient, so that's the number that is in front of the variable. Okay, the terms, like we discussed, terms are independent, so meaning that they are separated by addition or subtraction signs. And in this case, like we mentioned earlier, there are 3 terms that we can group. The first being 3x squared, the second being 2xy, and the third being c. And they're separated by 4 operators. Operators are similar to your order of operations, okay? So operators have that idea of adding, subtraction, could be multiplying, could be dividing, but your operator in this particular case is just your addition and subtraction sign where you see 4 that's highlighted. Okay, 5 is your constant. So your constant is going to be an existing number that exists on its own, and it's at the very end, okay? Actually, it's not always at the very end, but in most cases it is. But you might have an example where your constant in the future coming years of your math journey, you might find that a constant can be actually in the middle or the front or the end of your polynomial. So there's a couple of definitions you can go over there. I did in yellow highlight a couple of examples. So you can see here what a monomial, binomial, trinomial, polynomial. Okay, monomial means one term. So you'll notice there's just an x. Other examples could be if I had an xy. Binomial has 2 terms, so you'll see it's separated by that addition sign. Trinomial represents 3 terms, like what we had in our example above, where it's 1, 2, 3 terms. And then polynomial meaning many terms, okay? So I'll let you guys read over that. I also discuss in this little box here the difference between like terms and unlike terms. Okay, so like terms have the same variable. So in this case here, oops, you'll notice everything that's highlighted all have an x, and the exponent of each of those x's is 1. Okay, so meaning 2x, even though we don't see it, that exponent is 1. That's going to be very different for when we have something like 2x squared. Okay, or our highest, or our exponent itself is 2. Okay, so x and x squared are not the same terms, meaning you cannot group them together. Okay, you can also read that chart a little more closely in your lessons that you go over. Okay, so you're going to do a little matching activity here that's meant for you. You're going to do a little grouping activity here that's meant for you. Topic B, collecting and adding like terms. So you can see there are examples and there are steps that you guys can read over here. Okay, so discussing how to simplify. You can also do this by highlighting. Okay, so what I'm going to show you here actually, I'll do example B with you. And what I'm going to do is I'm going to highlight all the individual terms. So for instance, I'm going to look for x squareds. So I'm going to highlight all the x squareds with this green highlighter that I have. You can choose a different color. I can go with blue. I'm going to highlight all the x's. And then last but not least, I'll highlight all my constants. Now remember, they're constants because they don't have a variable associated with them. They are just letters. Numbers, sorry, no letters. Okay, so I'm going to now group them together. So I'm going to put all my greens together. So we're going to try and put and group all our x squareds. So I'll go back to my green. Oops. I want to make sure I'm consistent and I choose the same color. There we go. And then I'm going to group together my blues. And then I'm going to group together my constants, the numbers that exist on their own. Okay. Now I'm actually going to add like terms, okay? So if I add just the coefficients for the variables, remember you keep the variable, but you just add the coefficients. So we are adding or subtracting 1 minus 2. 1 minus 2 is going to be negative 1, and the variable is x squared. And I know this because if I subtract 1 minus 2, I get negative 1, which is why what's in green will be negative x squared. Oops. Okay, I'm then going to add my variables with x's. So 3 plus 7 is plus 10x. So you'll notice I do keep the variable once again. And then my constants, I'm just going to add 2 plus 4, which is plus 6. Okay, and yeah, that's pretty much it. We cannot group any more like terms. We just stop. Okay, perfect. So that shows you how to add like terms. Okay, the modules also review this concept, so you can also look through that as some live examples that you can work through. Okay, for degree, we'll talk about topic C. So for degree, if you want to find the degree of a term, this refers to the sum of the exponents of the variable. So the sum means when you add everything all up. Okay, now in reference to x cubed, x to the power 3, the degree would just be 3, right? Because we have nothing else to combine that sum with. There's only one variable. Now, if you look at B, we have x cubed y to the power 4. For that one, we're actually going to add 3 plus 4, which makes our degree 7. Okay? Now, when you're trying to determine the highest degree, we got to actually observe each term. So I'm going to look here to the left. I have x cubed y4, so that degree is equal to 7. And I'm going to look at x7y. Now remember what I said, y, if you do not see the exponent, that functions as having a 1 there, an exponent of 1. So really what that reads is, well, we have to figure out what 7 plus 1 is, which is 8. So the highest degree would be 8. Okay? You can also try these, so determine the degree of the following. So there's different terms that you can access and look at and determine which degree would each example have. Okay? Now there's some rules here for adding polynomials. And I've done a couple examples for you to follow. Okay, adding polynomials is pretty straightforward, and it's like what you did with collecting like terms. Okay, so you can review those 5 steps there and also try these practice examples, but read through the example 1 and 2 first before you begin. What I do want to go over a little more thoroughly is what happens when you subtract polynomials. Okay, so when you subtract polynomials, basically how this is a little bit different is everything that's in our second set of brackets. So I'm going to just take a look at example 1. When I'm subtracting, our rule is we're actually going to change everything that's in the second set of brackets to its opposite operative sign. So meaning the opposite of adding is subtracting. The opposite of subtracting is adding. So you can see here positive x squared now is negative x squared. Positive 2x is now negative 2x. Positive 3 is now negative 3. So everything in that second trinomial in that bracket set has changed to its opposite operative sign. And we went from a minus to a plus, and we're going to treat this like addition. Okay? So we're actually adding the polynomials. We're just changing everything in the second set of brackets to its opposite operative sign. Now, if you observe here, the first set, or first trinomial, nothing's changed with those terms. So you rewrite those terms, you just rewrite them without the brackets that contain them. Okay? So then you can see here, once you observe what your terms are, you're just adding terms like how we did above. Okay, so what you can do is you can select all of your like terms by using a highlighter if you have it at home. Okay, so this is like negative x squared and x squared. They become a like term. X, 3x, and minus 2x. They become like terms, and minus 3 and plus 5. Okay, once you group them together, then you can find out what it simplifies to. Okay. Exponent laws. Your exponent laws are discussed in your modules that you can go over, okay, and they actually exist here. Okay, so in this little box that I can highlight. So when you multiply, okay, multiplication of exponents, there's a certain rule. So the rule is you're going to keep the base and you're going to add the exponent. So if you have x to the power of m multiplied by x to the power of n, you're going to keep the base. I'll write it out. Keep base, add exponent. Okay, so for instance, if I were to find a multiplication law, one could exist like example 3. Okay, so what I would do, I would keep the base. I'm going to add the exponents. So 2 plus 3. And you know what? You don't even need to write that out. I just wanted to show you where it came from. That would be, oh, not multiplying, adding. Y to the 5. Okay. And then because we're handling coefficients, so keep in mind your coefficients are at the very beginning, we have to also multiply them. So that reads as 4 times 1, which would be 4y to the power of 5. Okay. An easier example, if we wanted to do this, x to the power of 3 multiplied, brackets means multiplication, okay? X to the power of 5, I'm going to keep the base and add the exponents. 3 plus 5 is 8. Okay, that's just one of the exponent rules that you can use. Okay, now there's also a division rule. Okay, so with division, we're going to keep the base, but now subtract the exponents. So I can show you an example. You know what, this is the harder example here. I'll start with an easier one. Okay, so I'll write one out. If I had x to the power of 8 divided by x to the power of 4, I would subtract the exponents, keep the base, subtract the exponents. 8 take away 4 is 4. So that would just simplify to x to the power of 4. In a harder example, okay, I always want you to be challenged because I've taught grade 10 academic many, many times, and I just want you to be aware of some of the things that you need to know for next year, okay? So we have 8a squared b divided by negative 2ab. Okay, so first, let's just rewrite the base. We're going to subtract the exponents, okay? So we'll start with a. So we have a squared minus a to the power 1. That's just going to be a, because 2 minus 1 is 1. Then b. I have b to the power of 1. Oops. Divided by b to the power of 1. So it's going to be like this. Okay, I know 1 minus 1 is actually 0. Okay, so really they cancel out. So I don't need to write that b there. That goes away. Okay, and we can look at now our coefficients. So we have 8 divided by negative 2. 8 divided by negative 2 is going to be negative 4. Okay, so as an answer, we would have negative 4a. You'll notice I always box my final answers in. That tells me that you're done. And I try to write all my solutions as neat as possible. I am writing on the surface of an iPad, so it's a little tricky sometimes. But yeah, those are our first two rules, okay? There's also something called power of a power law. Okay, so power of a power law would be any exponent raised to another exponent, you would just multiply. So for instance, x to the power of 4 raised to the power of 5, that would be multiplying 4 times 5, which is x to the power of 20. Okay, we can do the more trickier example. And actually, that trickier example is our product rule extended. So if we take a look at this rule, we have x to the power of m times x to the power of n, all raised to the exponent of a. So you'll notice that a gets multiplied into m and n. Okay, so how I would write this here, it would be 2 also gets the exponent raised to the exponent 3. And I'm going to, actually, we don't need brackets. I'll just rewrite it out. 2 to the power of 3, x to the power of 6, because I'm going to multiply 2 times 3. Okay, so now if you're going to do this in your calculator, 2 to the power of 3 is like saying 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8. So this final answer would be 8x to the power of 6. Okay? Okay, so that goes over those 4 exponent laws that are expected to be known for this unit. Okay, you can try a couple of these examples as well. And your exponent rule practice with the answers at the bottom so you can compare your answers. Okay. I want to do one more discussion just on distributive property, and then I'm going to end this video, and then I'll make a new video just on algebra. Okay, so how to solve for x or any variable. So I'll just finish up one more example here, which is the distributive property. Okay, so distributive property is this idea when you take a term, so in this case a, and you're sharing it inside the bracket. Okay, I say share, and the reason why you're sharing it inside the bracket is because you're trying to multiply inside the bracket. So when you multiply inside the bracket, this actually ends up looking like a times b, and then lastly a times c. Okay, and then you're going to add them because there's that addition sign. Similarly, if there's a subtraction sign, you would just subtract depending on the knowledge of your integer laws. Okay, so hopefully you do know your integer laws and you're aware where 2 positives make a positive, 2 negatives make a positive, and a negative and a positive combine make a negative. Okay, these are your integer laws. Okay, so for distributive property, I'll show you here. I'm going to draw little arrows just to symbolize the action. So I'm going to go and share 3 by multiplying 3 times x, which is just 3x, then multiplying 3 times 5, which is 15. If you can collect like terms, go for it, but if you can't, we'll just leave it as is. Okay? We'll then go into sharing negative 3 into the brackets. So it's negative 3 times x, which is negative 3x. Then negative 3 times negative 2. 2 negatives make a positive, so that's actually plus 6. Okay, and then last but not least, we will share 3x inside this trinomial. Okay, so if you're sharing it into a trinomial, it means you will be left with an answer with 3 terms. Okay, unless once you collect like terms, things cancel out. But for now, let's see what happens. Okay, so we're going to share 3x into the bracket. 3x times x squared. So that's multiplying. And whenever you multiply with the same base, remember we keep the base. So I'm going to keep x. 3 times 1 is 3 anyways. And then I'm going to add the exponent. So that's like 1 plus 2. Okay. And then I'm going to multiply 3x times negative 2x. That would be negative 6x squared. And then last but not least, 3x multiplied into the last term, which is 1 plus 3x. So once again, please try these last couple of questions, okay? I'm going to pause for now, and I will make a separate video on solve equations, just because it's a really important concept and I just want to handle that solely. Okay, so thanks for tuning in to the first part of the day 2 notes. I will make one more video coming right up that you should watch after you try the first 7 sections.